Hello class, this problem is from chapter 10, 10.5. We're just starting the confidence intervals. In this problem, this is the first one where you have to go through the four-step inference toolbox. And if you notice, I have the problem off to the right. It's really small if you can read it. But when we start going through the problem and we're reading it, we notice in there that it says that it's normally distributed. It says that the mean of the population of all measurements is the true concentration of the specimen. It says the standard deviation of this distribution, or the population distribution, is going to be 0.0068 grams per liter. And this is the only time in the problem they actually mention units. So if you're not careful, you'll miss the units. Then it says that the laboratory analyzes each specimen 3 times. So that means that the sample size is 3, and they give this down here. It says construct a 99% confidence interval, so that's what we're looking for there, for the true concentration of mu. And that's how you're going to state your answer, so you want to make sure that you're well aware of that. Now, I've already got it typed up and worked out for you. But if we look at it, the population, it's kind of vague in this particular one. It's all batches of the pharmaceutical product or anything that the manufacturer manufactures. So there's a number of ways that we can phrase this. The parameter that we're looking at here is the concentration of the active ingredient, and you get that from the first line. So if you look, and then we go up here, we can, let me get a thinner line here, very fine point here. If we underline this, that we're analyzing a specimen from each batch to verify the concentration of the active ingredient. So that's what we're measuring, and that's what you have to ask yourself for the parameter. Sometimes it can be kind of difficult. So we're looking for the concentration of the active ingredient. And not every problem I give you is this vague. Step 2, you're going to state first what you're doing and why you're doing it. You're looking for a 99% confidence interval, and you have to tell me if it's going to be means or proportions. So in this particular case, we're looking for means. How do you know that? Well, do you see proportions anywhere in the problem? No. You do see mu, though. And there's 3 numbers that you have to average together to get x bar. So that we're doing it for means. The first thing we need to check in step 2 after we state what we're doing is rule of thumb number 1. Can we modify the standard deviation? Well, I don't know what the population is here. Is it greater than 10 times 3? Are there more than 30 batches? We don't really know. So we have to write proceed with caution. That's very, very important. So we're going to proceed with caution. And then the problem tells us that it's normally distributed. So we're good there. I wrote down the z-star for you. It's 2.576 for a 99% confidence interval. So I had to handwrite the next ones because I didn't want to go into math type for all of this stuff. So the average of the 3 samples is x bar, and it's 0.8404 grams per liter. Then we plug it into the confidence interval formula. So 0.8404 plus 2.576, which is our z-star, times our modified standard deviation. When we work it all the way down, we get 0.8303 to 0.8505. Now make sure that you have it in the right order. Then step 4 is always going to start off with how confident you are. I am 99% confident that the true mean concentration is between 0.8303 and 0.8505 grams per liter. Now the back of the book has 0.830 and 0.851, so they've rounded it to 3 decimal places, but we're going to take it out to 4. Now, this can also be worded that 99% of the time in repeated samples that this range would capture the mean. So, we don't want to really worry about wording it that way. We can get away with always stating I am 99% confident or I am 95% confident. So you want to make sure that you use that. And you also want to put something from the problem in there, like the mean concentration of the active ingredient. You can't just say that I'm 99% confident that the interval is between 0.8303 and 0.8505. That's too vague. You need to put something from the problem so that the College Board knows that you've actually read it. Okay, so I'm going to go ahead and post this on YouTube. You can send me back any questions that you have on this or any questions on any of the other problems. I'll try to get to the next section tonight. I'll send you another one. Hope you are all doing well.